It's November 25th, 2018, and we're outside the hotel in Sudbury, Ontario, and they have actual real rocks make up their wall, but I'm not sure where they're from. I didn't encounter any purple quartzites out here. Okay, so we came out here for several reasons. The main one being because Sarah had never seen Sudbury, Ontario, and it's been years and years since I've been here. And I wanted to record this at a rock outcrop or something. We're actually in the hotel parking lot still, but with the highway, and this is actually a pretty built up area, it's really loud. So I just want to talk a little bit about the geology. Essentially where we are right now, we're on the south rim of a 1.850 billion with a B year old impact crater that has been deformed through several orogenies to be kind of elongated now. We know the age of the crater for sure. As a matter of fact, this piece that I bought at the ILSG meeting last year is Sudbury ejecta from the impact crater right here. However, we are on the south rim, southeastish, and we're actually, the lot itself is actually on metasedimentary or the Nipissing diabase intrusions. We wanted to go to the Dynamic Museum because there's some outcrops in the lot there, but they're closed for the winter. The actual impact itself is just to the north of us, and it's a huge, huge area. It is estimated to have been at least, surface area-wise, twice the size of the one that killed the dinosaurs. So it was a big event. Now back then all we really had were microorganisms, but it probably did cause some sort of extinction level event. But, you know, it's hard to tell from the fossil record, and all you have is stromatolites. Okay, so we are at Dynamic Earth. They are closed for the season. We said, screw it, we're going to show up anyway. I thought this might be covered with snow, but it isn't. This is the McKim formation of the Elliott group, which is part of the Huronian supergroup, which is part of that sedimentary rock package. Well, at the bottom, it's volcanic, but most of it's a sedimentary rock package from about 2.45 to about 2.2 billion B years ago. This is near the bottom of that sequence. This is sedimentary, and what you can see is you see all these lines. Now these lines are here for two reasons. First of all, they are the bedding and lamination within the McKim, which is generally a siltstone and slate with some proto-quartzites in it. And another reason is because the glaciers, when they moved through this area, they kind of left some striations in order to gouge out the bedding planes, and you can kind of see how they undulate and stuff, but that undulation's just apparent. If I were to measure this, everything's pretty linear and straight. So what we had here is, now we are we're still on the south limb or south area of the Sudbury impact, but I just wanted to show you this outcrop because I saw it in the book and I thought it was pretty neat. There are some secondary things going on here at this particular outcrop because of the impact. I'm not going to talk about them here because I don't see anything exposed right here. Sorry, I guess those are the falls. Chutes! And the rock here is a bit perplexing. There seems to be a mix of igneous and metasedimentary, but I don't know, I'll have to look at an actual geologic map to be sure. It looks like mostly gray lackeys. To proto-quartzites, but like I said, it's hard to tell. I haven't seen any good, natural broken fractures to get a real good look at it. Well, there's a lot going on at this outcrop. You can see these reddish quartz monzonite granite intrusions. They trend different directions. I measured that one. That's a big white quartz inclusion, but it's weird. The host rock, see this one? The host rock to the west is different than the host rock on top of it. So it's probably followed a fault at some point. But I'm going to cross and get going.